Welcome to the unit on straight lines, midpoints and perpendicular bisectors. The objectives for this session are to find the coordinates of the centre of the circle given information about its diameter and vice versa, and find the equation of a perpendicular bisector of the diameter of a circle. The midpoint of a given line segment can be found by averaging the x and y coordinates of its endpoints. The midpoint of the line segment shown is x1 plus x2 all over 2, comma, y1 plus y2 all over 2. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's have a go at example 1. This asks you to suppose the line segment AB is the diameter of a circle, where A equals -3, 5 and B equals 2, 4. Find the coordinates of the centre of the circle. So let's solve this example. The centre of the circle is given by x1 plus x2 all over 2, comma, y1 plus y2 all over 2, where x1 is -3 and x2 is 2, and y1 is 5 and y2 is 4. So tidying up gives us that the coordinates are -1/2, comma, 9 over 2, as shown. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. So example 2 states the line segment QR is the diameter of the circle centre 3, -2. Given that Q equals 7 minus 5, find the coordinates of R, which equals AB, where A and B are both in the real numbers. So let's solve this example. 3 minus 2 is the midpoint of AB and 7 minus 5. Using the formula for the midpoint, let's substitute in all these values. So here x1, y1 is 7, -5, and x2, y2 equals AB. Therefore, 3 is equal to 7 plus a all over 2. And -2 equals -5 plus b all over 2. So solving for a gives a equals -1 from the first equation, and solving for b from the second equation gives b equals 1. Therefore, r is equal to -1, 1. We will now look at perpendicular bisectors. The perpendicular bisector of a line segment AB is the straight line which is perpendicular to AB and cuts it through its midpoint. Let the gradient of AB be denoted by m. Then the gradient of its perpendicular bisector L will be -1 over m. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let C be a circle and let a segment AB be a diameter of C, where A equals -2 minus 3 and B equals 6, 3. The line passing through C and perpendicular to AB is denoted by L. Find the equation of L. So let's solve this. The midpoint of AB equals 6 plus -2 over 2, comma, 3 plus minus 3 over 2. This is, of course, 6 minus 2 over 2 and 3 minus 3 over 2. So we have that the midpoint of AB equals 2, 0. Now the gradient of AB is equal to 3 minus minus 3, or the change in y, over 6 minus minus 2, which is the change in x. This equals 6 over 8, or 3 over 4. Therefore, the equation of L is y equals minus 4 over 3x plus c. This is because when the gradients of both these lines, which are perpendicular to each other, are multiplied by each other, give minus 1. However, we know that 2, 0 lies on the line. Therefore, substituting these values into the equation will give us the value for c. So y equals 0 goes here. Of course, the gradient is minus 4 over 3. X equals 2 goes here. And now we can find c by rearranging the equation. And hence we have that c equals 8 over 3. Therefore, our equation is y equals minus 4 over 3x plus 8 over 3. This brings us to the end of this session. If you have understood its contents, you should be able to find the coordinates of the center of the circle given information about its diameter and vice versa, and find the equation of a perpendicular bisector of the diameter of a circle. Thank you very much for listening.